Okay, 7.9b says, and this is page 9. Okay, page 9 on the measurement and geometry. A cylindrical barrel has a diameter of 19.875 inches. Which of the following is the best estimate of the circumference? Okay, so cylindrical, fancy word for like a soup can shape. Okay, can look like this. Has a diameter of 19.875. Making that 20. Why? Because I can. That means diameter goes all the way across, remember? Radius goes to the middle, diameter all the way. And we said that's 20. Which of the following is the best estimate of the circumference? So we're looking for circumference. Not guessing, but looking at my formula chart, I have C equals pi times D, or I have C equals 2 pi r. Since they already give me diameter, I might as well use this formula. I am estimating because I'm using 3 for pi. 3 times 20, and that makes 60, knowing that this is lower than actual because of the way I rounded. Looking at my choices here. Uh-oh, something went wrong. What did I do? Because these are really much smaller. Well, let's double check. Oh man, look at that. Now, this is why you read and reread. This says it's measured in inches, and it wants to know, of course, the area, the circumference in feet. All right, so 20 inches, we can still use this because it's a single dimension that I'm measuring. Now, if it were area or if it were volume, we would have to convert first, but this one we're okay with. So 60 inches, we would take this, and we know that there are 12 inches in a foot. So how many inches are in, or how many feet, are in 60? I believe 5. Yep. So 5 feet. That's my answer. Again, this one works by converting at the end only because this is basically asking for perimeter. If it were asking area or volume, we would absolutely have to convert first. Okay, meaning instead of using 20 inches, I would have converted that into feet before solving, but I'm okay on this. Oh, good question. Okay, continuing on page 9. This is going to be a very familiar shape. I bet you're going to have a question that looks like this. The park model below consists of a rectangular area and 2 semicircle areas. The area of the rectangular part of the park is 60,000 square yards. Okay, so let's read that again. The park has a rectangular area, 2 semicircle, area, rectangular, 60,000. Write that in here, 60,000. And that's for this space here. Which of the following is closest to the distance along the perimeter of this park? Okay, distance along perimeter. Perimeter has the word rim in it. That means outside edge. Outside edge. And let's be sure, what are we doing with the semicircles? Which of the following is closest to the distance along the perimeter of this park? Okay, well, this is part of it, so we're going to have to look at that. 60,000, which means to find area, I would have done 300 times what? Oh, good question. Okay, area equals, it's going to be base times height, and I'm looking at just this rectangular piece. Area we already know is 60,000. Base we could call 300. Height is unknown because I want to figure out what this measures right there. That'll help me with my circles too. So I am dividing by 300. Remember, top and bottom zeros mean that I can simplify by taking off, that's dividing by 10, right? Scooting your decimal over once, dividing by 100. I'm left with 600 over 3. Top dog in the house. 3 into 6 is twice. That's 6. 0, bring down the 0. 3 into 0 is 0. 3 into 0 is 0, and I'm done. But what this tells me is just simply the other measurement here. This is by 200, and then over here obviously is also 200. Okay, and this bottom one, if that top one is 300, this one is also 300. Okay, so I know only part of it. I know 200 by 300 is the distance there, but I still have these semicircles. How do we have or find, excuse me, area for a circle? Without guessing, you would look at your formula chart. Area equals pi r squared. Okay, area equals. We remember that we're using 3 for pi because it makes things easier. And then what's my radius of my circle? Well, considering this is like my circle here, diameter all the way across is 200. So what's my halfway point? 100. Good answer. So this is 3 times 100 squared. Remember, PEMDAS says I've got to multiply first. This is going to be 100 times 100. Yikes. It's going to be 1, 2, 3, 4 zeros. Okay. Close that up. And then multiply by 3. 3 with 4 zeros. So 30,000 is for a full circle. Do I have a full circle? Well, technically no. I don't have a full circle here, but I have a half circle and I have another half circle, which together make a full circle. So this is for a full circle. What do I do now? Ooh, aw, man. I think I wasted some time doing something. I found the area. Is the area even needed? Of course it's not, because, hello, Miss Ortega, it says perimeter. Yikes, that's not important. What I do need to figure out, though, is what is this edge? Because it does say perimeter. Okay, we're not far off, so perimeter. In a circle, that's called circumference. I can use my diameter, or I can use my radius. It doesn't matter. Let's try radius 1. So 2 pi times radius. Man, I hate it when I mess up. Pi is going to be used for 3. Radius is going to be 100. Circumference, 2 times 3 is 6. Cross that out. And 6 times 100 is 600. Still not everything. And in fact, this is the circumference of a full circle, which is kind of good because here's half of my circle, which half of it would be 300, okay, along this edge. And then over here would also be 300 along that edge. So, perimeter along. All right, let's start adding. 300 plus 300 plus 300 plus 300. Sounds like 1,200 to me. Looking at my choices, letter D has to be correct. Dang, I'm sure glad that I went ahead and read again. If I'd have read sooner, I'd have realized that finding area was not important, but I got there.